Ferrari just revealed a rear diffuser so aggressive, it could decide the entire 2026 championship. And almost nobody realized how extreme it actually is. This is not a minor upgrade. This is a complete aerodynamic gamble. A steeper expansion angle. New Venturi channel geometry. L-shaped rear wing pillar elements creating a double extraction effect. Which, in simple terms, means more suction under the car. More rear downforce. More performance. But only if it does not stall. Because when a diffuser like this loses airflow, the downforce does not fade. It disappears. Instantly. On day 1 in Bahrain, Ferrari completed more than 140 laps. They showed serious pace. Top 3 potential. But they also revealed something dangerous. The car has 2 personalities. Calm in one run. Unstable in the next. Lewis Hamilton fought snap oversteer. Charles Leclerc unlocked explosive rotation. Same car. Different window. So now the real question is this. Did Ferrari just build the highest performance ceiling on the grid? Or the most sensitive rear end of the new era? Because if this diffuser works consistently, the SF26 becomes a title weapon. If it does not, it becomes a weakly balancing act. And what we are about to break down explains why this rear diffuser is not just bold. It is a calculated risk that could redefine the fight against Red Bull. Subscribe now, because this battle is only getting started. The first real clue that Ferrari was hiding something big did not come from the timing screens. It came from a crane. For a brief moment in the garage, the SF26 was lifted, and the underside was exposed. That is when the paddock saw it. The diffuser geometry was completely different from Barcelona. Much steeper expansion. Much more aggressive kickline. The tunnels looked wider. Deeper. Hungrier. This is critical. Because under ground effect regulations, the diffuser is not just a component. It is the engine of aerodynamic load. Air enters the Venturi channels at high speed. It accelerates under the floor. Then it expands at the rear. The more controlled that expansion, the more suction you create beneath the car. And Ferrari increased that expansion dramatically. Which means one thing. They are chasing peak downforce. Not safe downforce. Peak. But here is the danger. A steep diffuser angle demands perfect airflow sealing along the floor edges. If outside air leaks in, the pressure difference collapses. When that happens, the diffuser stalls. And when it stalls, rear grip vanishes instantly. That is why this concept is so extreme. It offers huge aerodynamic reward, but only inside a narrow operating window. And Ferrari knows it. That is why they removed the double metal floor support they used earlier in Barcelona. That brace was there to pass flexibility tests. But it disrupted airflow. Now the floor is structurally stiffer on its own. Reinforced carbon fiber layout. Cleaner underside. Less obstruction before air reaches the diffuser. Everything flows smoother, which increases efficiency and reduces drag. Then there are the small L-shaped elements mounted near the rear wing pillars. They look minor. They are not. Those pieces energize the airflow exiting the diffuser. They connect it with the suction created by the beam wing. It is almost like stacking aerodynamic extraction zones. The diffuser pulls. The rear wing pulls harder. Double extraction. More load without massively increasing wing angle. That explains something we saw in Bahrain. Ferrari looked very strong in acceleration sectors. They were gaining speed quickly out of corners. The GPS traces suggest impressive traction. And here is where it becomes fascinating. This diffuser concept depends heavily on platform stability. Ride height control is everything. If the car squats too much under power, airflow detaches. If it dives too aggressively under braking, the floor scrapes. Either scenario disrupts the airflow feeding the diffuser. Ferrari anticipated this. They introduced a more aggressive anti-dive setup on the front suspension. The upper wishbones sit at a sharper angle. The objective is simple. Keep the nose stable. Protect the aerodynamic platform. Maintain consistent ride height through braking zones. That mechanical adjustment is not random. It is there to protect the diffuser. Which tells you how central this component is to the entire car philosophy. Now think about the implications. This is not an isolated upgrade. The front wing was revised to push dirty air outward. The S-duct evolution near the halo cleans airflow over the chassis. The floor edges are refined. The suspension geometry is recalibrated. Everything is feeding one goal. Maximize diffuser performance. And when you design a car around one aerodynamic core principle, you either unlock something extraordinary, or you create a dependency that becomes difficult to manage. On day 1, Ferrari showed flashes of both. Hamilton struggled in the morning. Initial understeer. Then sudden rear instability. That suggests the aerodynamic window is sharp, sensitive, Leclerc, in the afternoon, found more rhythm. Different suspension setup. Slightly stiffer rear. More rotation control with throttle. Same diffuser. Different mechanical balance. Completely different behavior. That tells us the potential is real. But the window must be tuned precisely. And that is where development becomes everything. Because if Ferrari widens that window, this diffuser could deliver peak performance levels that few rivals can match. But if they fail to stabilize it across varying track conditions, it becomes a high-speed gamble every weekend. And the most important detail is this. Ferrari brought this to day one. Not mid-season. Not hidden under covers. Day one. Which means they believe in it. They trust the data. They trust the simulations. They trust the correlation between wind tunnel and track. Now the only question is whether reality matches the theory. Because if it does, the SF26 may have just revealed the most ambitious rear aerodynamic concept on the grid. And that changes the championship conversation immediately. But here is where this story becomes even more intense. Because the diffuser alone does not explain the full picture. What happened between the morning and the afternoon sessions revealed something much bigger. Lewis Hamilton stepped into the SF26 in the morning. New team. New environment. New aerodynamic philosophy built around an extremely aggressive rear platform. And immediately, the car showed instability in medium-speed corners. Entry understeer. Then snap oversteer on exit. That kind of balance shift is not random. It usually signals a rear aerodynamic platform that is highly sensitive to load transitions. When braking shifts weight forward, the rear ride height increases slightly. If the diffuser loses optimal expansion flow at that moment, rear grip drops. Then, when throttle is applied and the rear compresses, airflow can suddenly reattach. That creates the snap. It is subtle. But at the limit, it is dramatic. Now here is what makes this fascinating. During the lunch break, Ferrari reportedly adjusted rear suspension stiffness. Small mechanical changes. But the impact was clear. Charles Leclerc went out in the afternoon. And the car looked alive. Sharper rotation. More aggressive turn-in. Stronger exits. He attacked turns 11 and 13 with confidence. That suggests the diffuser concept itself was not failing. It was simply operating inside a very precise mechanical window. And Leclerc found it. Or at least came closer. This is where Ferrari's situation becomes dangerous for the rest of the grid. Because if the issue were fundamental aerodynamic stall, lap times would collapse. Instead, the performance improved with setup. That means the concept has depth. It is tunable. And tunable platforms can be refined. Ferrari completed more than 140 laps across both drivers. That is not the behavior of a fragile package. The power unit ran clean. Deployment looked strong. In fact, GPS traces showed impressive electrical acceleration out of slower corners. The hybrid system appears efficient, which enhances the diffuser effect. Why? Because strong traction plus high rear downforce creates devastating exit speed. And in Bahrain, exit speed defines lap time. But here is the psychological layer. Red Bull looked stable. Almost effortless. McLaren looked consistent. Predictable. Ferrari looked explosive. High peak. High sensitivity. And that profile is both inspiring and terrifying. Because championships are rarely won by the safest car alone. They are won by the car with the highest development ceiling. And this diffuser may represent exactly that. However, the narrow operating window cannot be ignored. Ferrari engineers were studying aero rake data intensely during Leclerc's early afternoon runs. That tells you they were validating airflow consistency toward the diffuser. If the data confirms stable extraction across ride height variations, confidence increases massively. If not, they face a season of fine margin tuning. There is also the strategic implication. If Ferrari has unlocked a double extraction rear architecture that produces more load without adding excessive drag, they can run smaller rear wing angles. Smaller wing angles mean better straight-line speed, which makes overtaking harder for rivals, which increases defensive strength during races. That shifts championship dynamics. Suddenly, qualifying pace becomes even more decisive. Track position becomes more valuable. And rivals must decide whether to copy this aggressive expansion philosophy or stay conservative. Copying is not simple. The entire floor, suspension, and rear wing integration must align. This is not a bolt-on upgrade. It is a full architectural commitment. And Ferrari has committed. On day one. That is the message. Not experimentation. Commitment. But here is the unresolved tension. Hamilton and Leclerc gave similar feedback about mid-speed instability. They agreed on the problem. They differed slightly on the solution. Hamilton asked for more front load to anchor the nose. Leclerc preferred managing the rear with throttle control. 2 elite drivers. 2 approaches. 1 aerodynamic core. If Ferrari can harmonize both preferences within this diffuser-driven philosophy, the SF26 becomes adaptable across circuits. If they cannot, internal compromise begins. And compromise limits development direction. So day 1 in Bahrain was not about topping the timing sheets. It was about revealing intent. Ferrari is not chasing incremental gains. They are chasing aerodynamic dominance from the floor upward. The diffuser is not just a component. It is the heart of the car. And what we saw was only the first glimpse of its true potential. The next sessions will determine whether this is the beginning of a title-defining innovation, or the start of a season spent searching for balance. And the entire paddock is watching that rear end very carefully. Now let us zoom out. Because what Ferrari revealed is not just about lap time in Bahrain. It is about the direction of the entire regulation cycle. When a team redesigns the diffuser this aggressively on day 1, they are not thinking about race 1. They are thinking about race 10. Race 15. The championship fight in the final third of the season. Here is why. A diffuser with a steeper expansion angle has a higher aerodynamic ceiling. That means as the team refines the floor edges, refines vortex control, refines beam-wing interaction, the potential gains stack faster than on a conservative platform. Conservative designs improve linearly. Radical ones improve exponentially, if stabilized. And Ferrari appears to be betting on exponential growth. But this introduces pressure. Because correlation becomes everything. Wind tunnel data must match track airflow behavior. CFD simulations must match real ride height sensitivity. If the diffuser stalls even slightly under unpredictable track conditions, the development curve flattens. And rivals catch up. So what did day 1 tell us about correlation? Ferrari's aero rakes in the afternoon runs were not random. They were validating airflow cleanliness toward the diffuser throat. The early data suggests the flow is indeed cleaner than in Barcelona. More stable under steady-state conditions. But still sensitive under dynamic load shifts. That is why the anti-dive geometry matters so much. That is why rear suspension stiffness adjustments change the car's character so noticeably. The platform must remain flat, predictable, disciplined. And here is where this becomes a championship-level question. Red Bull's philosophy appears stable and wide in operating window. McLaren's car looks tire-friendly and balanced. Ferrari's SF26 looks sharper, more reactive, potentially faster over a single lap. If qualifying pace increases due to this diffuser efficiency, Ferrari could control track position. And in modern Formula 1, clean air is everything. Clean air protects the diffuser. Clean air protects tire temperature. Clean air protects race pace. But there is a hidden risk. An aggressive rear extraction concept often increases sensitivity to crosswinds. Bahrain had wind. And there were moments where the SF26 looked slightly nervous mid-corner. Not dramatic, but noticeable. If wind alters pressure distribution at the diffuser exit, extraction efficiency fluctuates. That would explain the morning instability Hamilton felt. And if that sensitivity remains, circuits like Silverstone or Austin could amplify it. However, the fact that Ferrari completed heavy mileage without mechanical failure is a strong signal. The power unit handled thermal loads. The hybrid deployment looked consistent. That means the aerodynamic gamble is not being undermined by reliability. At least not yet. And this is the key difference compared to risky concepts of the past. Ferrari's risk is aerodynamic, not mechanical. Mechanical fragility destroys seasons quickly. Aerodynamic sensitivity can be tuned. And tuning is exactly what they were doing between sessions. Now imagine this diffuser concept 3 races from now. After data from Bahrain. After data from a high-speed circuit. After data from a street track. If the engineers widen the operating window just enough, the SF26 could combine Leclerc's natural rotation control with Hamilton's precision braking style. That is a frightening combination. Because one driver extracts peak performance, the other extracts consistency. If both align with the same aerodynamic philosophy, Ferrari becomes complete. But if the diffuser remains narrow in its performance window, strategic compromise begins. And once compromise begins, development splits. One direction for stability. One direction for peak load. And divided focus slows progress. So day 1 was not about who topped the charts. It was about intent. Ferrari revealed a diffuser that prioritizes maximum extraction. They revealed confidence in simulation tools. They revealed willingness to accept short-term instability for long-term gain. That is not cautious.